Today we're going to be exploring and using the converse of the Pythagorean Theorem. And no, Converse does not mean the shoe brand, although I do love me a good pair of Converse sneakers. We'll talk about what the converse means in a second. Just as a reminder, the Pythagorean Theorem says that if we have a right triangle, then the sum of the squares of the two legs is equal to the square of the hypotenuse. The converse of this is also true. So let's talk about what a converse is so that we know. And by the way, in case you're wondering, this is like the super long way to write this, and this is actually when Pythagoras originally came up with this, he actually said something like this. But we say it a squared plus b squared equals c squared because doesn't that take a lot less time to write and say? Anyway, the converse is an if-then statement where the if and the then parts have been switched. So an example is if you got above 92%, then you got an A. The converse, you're going to swap the if and the then. If you got an A, then you got above 92%. And the converse and the original statement are not always going to be true. Sometimes you swap them, and that actually means that it's no longer true. So if you got above 92%, then you got an A. If 92% is the cutoff, then this is true. In that scenario, if you swap it, if you got an A, then you got above 92%. This could be false if, like, maybe your teacher gave you extra credit. Maybe they eliminated an assignment for you. Maybe they rounded up and it was like 91.5, but they were like, close enough. And you actually got 91.5%, but you got an A. So the converse of a statement is not always true, but the Pythagorean theorem is special because you can swap it and it will still be true. So the Pythagorean theorem says if you have a right triangle, then the sum of the blah, 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 a squared plus b squared equals c squared. And the converse is if a squared plus b squared equals c squared. If you looked at the sides and you found that the squares of the legs equaled the square of the hypotenuse, then you're guaranteed it's a right triangle. So on the first one, we don't know what all the lengths of the sides necessarily are. We just know it's a right triangle. On the second one, we know what the lengths of the sides are and we know that this part is true. So what you're guaranteed for the Pythagorean theorem, what you're given as guaranteed is different. So we're going to check and see if these are right triangles. Notice how none of them have like this little guy? That's because we don't know if it's a right triangle. Okay, we're going to check this one. How do I know which sides to plug into a squared plus b squared equals c squared? Remember that c squared is really the only one that matters. A and b can be either of the other two. And it makes sense that you would put the longest one in for C because it is the sum of a squared plus b squared. So it makes sense if you're adding two things together to get the third thing, that the third thing should be a bigger thing, right? So we're going to put the longest side in for C. So the longest side of these is 15. And then I'm going to just put in the others as I see fit. So we want to know, is this equal? If it's equal, then it's a right triangle. If not, it's not a right triangle. So let's check. I have these memorized, so I can just do this without doing the calculator. 12 squared is 144. 9 squared is 81. And 15 squared is 225. We still don't know if these are equal. Now we want to know, does 144 plus 81 equal 225? And it does. Those two are equal. So we're going to say, yes, it's a right triangle. Oh, we're just going to say it is. It doesn't ask, is it a right triangle? It is a right triangle. Woohoo. Okay, let's go ahead and do this hard one over here. All right, so I'm not entirely sure which one of these is the longest, but looks like 16 is the longest. Let's check real quick. I'm just going to estimate how big this is. It's kind of close to 6, and 2 times 6 is 12. So 16 is going to be longer. I'm going to put these into my a squared plus b squared equals c squared. And 16 is going to go in for C. And I'm going to put 10 squared over here. Then 2 times the square root of 39 squared. You put the whole thing in parentheses because we want to square the whole thing. And then this is 100. 16 squared. Why is this one always so difficult for me? Oh, it's 256. Whew. Took me a second. All right. Then when you square terms that have been multiplied together, you're squaring and you're going 2 times the square root of 39 times itself. Now you could technically move all these around. You could multiply these two together and you could multiply these two together. So really it's like we're squaring the first number and the second number. So the first number is 2 times 2, which is 4. And then the second number is the square root of 39 times the square root of 39. And remember, the square root of 39 is the number that times itself equals 39. So whenever you have a square root of a number times itself, it's whatever the number was inside. Okay. So now 4 times 39 is 120 plus 36, 156. Does 100 plus 156 equal 256? It does. So this is also a right triangle. I'm guessing that the one in the middle is not a right triangle. So if it were not equal, then it would not be a right triangle. Okay, so if a squared plus b squared does not equal c squared, what type of triangle is it? Because it's not a right triangle, right? So if c squared is exactly the same as a squared plus b squared, then we have a right triangle. If c squared is smaller than a squared plus b squared, then that means that that longest side is a little bit shorter. And a shorter side means a smaller angle. So then we call it an acute triangle because that means that no angle is 90 degrees or bigger. So if c squared is smaller, then it's an acute little triangle, acute triangle. If it is greater, then that means that the hypotenuse is longer than it would be if it were a right triangle. Hypotenuse, it's not a hypotenuse now. And so that leads to a bigger angle. So this is going to be called an obtuse triangle. Obtuse means it has one angle that is bigger than 90 degrees. Let's go ahead and try a couple. So I'm going to do kind of a little bit of a super speed round. We're going to put this into a squared plus b squared equals c squared. And we got 17. And then I'm just going to put these in numerical order because it's easiest for me. Then square them all. I think this is 289. So 81 plus 144 is smaller than 289, kind of by a lot actually. So 289 is bigger. And since 289 is bigger, we're going to say this is an obtuse triangle. Okay, let's go ahead and do this one over here. We're going to put it into a squared plus b squared equals c squared. This is going to be 4.8 squared plus 28.6 squared. And we're going to see, does it equal 29 squared? Whew, I can't do all those numbers in my head. I'm going to go over to a calculator. First, let's find out what 29 squared is. 841. All right, let's go and write 841 over here. And then I need, let's go back and look. 4.8 squared plus 28.6 squared. 4.8 squared plus 28.6 squared. Now make sure that you put all of these guys in the calculator in order because don't round them. You want them to be exactly equal. So if you need help doing that, please let me know. Those together equals 841. So we have 841 equals 841. This is a right triangle. And remember that if C were smaller than a squared plus b squared, then it would be an acute triangle. Good luck.